Even and odd functions. All right, I have 4 examples to kind of explain this concept. An even function is symmetric with respect to the y-axis. Okay, so in other words, these 2 sides, the left and the right, are mirror images of each other. If you imagine the y-axis being a mirror, and same here. And if you want to verify that symbolically, basically, whatever number you put in, let's say I pick an x, okay? x1. And it takes me to a certain y value, right? Well, on the other side of the graph, if I put the opposite sign in, so minus x1, I'm going to get the same, well, it doesn't look like it, but I'm going to get the same output. Okay, so the 2 sides give me the same y value, whether I put in a positive or negative. So if you want to show symbolically that a function is even, what you do is you plug in a negative x, and you should get the same output. So here, if I take f of negative x, that is negative x squared, and you'll notice that's x squared. So whether I put in a negative or a positive, I'm going to get the same output. And same here, if I take f of minus x, put that in the absolute values, that's the same as the absolute value of x. So symbolically, I've shown that this is an even function. So whatever x you put in, if you put in the minus x, you're going to be at the same height. Okay, now, what does it mean to be odd? Well, we have a different kind of symmetry. It's called symmetry with respect to the origin. And that just means if you rotate your function 180 degrees, so if I rotate this 180 degrees, then I'm going to get the same graph. And you can see that's true. If I take this graph and rotate it 180 degrees, I'm going to get the same graph. That's how we show that a function is odd graphically. Now, symbolically, what does that mean? That means that if I have a point here, let's call it x, y, and I rotate it 180 degrees, it's going to take me over here to minus x minus y. Okay, and so when I put in the opposite sign for x, I should get the opposite output. So let's try that symbolically. I put in a minus x, I take minus x cubed, and that cube means I'm going to have a negative x cubed. So this is the opposite of our original function, the opposite sign. And here, similarly, if I put in f of minus x, I get the cube root of minus x, which is minus cube root of x. And that is the opposite sign of our original function. So that's what determines an odd. So let's just recap what I said. If for even functions, if you plug in the opposite, like a negative x, you're going to get the same output as you did for your original function. And for odd functions, if you put in the opposite, so negative x, you're going to get the opposite of the original function. I hope that helps understand and sort this out. And graphically, we say this is symmetric with respect to the y-axis. And here we say it's symmetric with respect to the origin. So that's even and odd functions for you.